Okay, so the last part of this experiment today is to look at the mass and the volume of something that's in the gas phase. Um, so the procedure is going to be a little bit more complicated as to how we record the mass and how we record the volume of something that's in a gas, right? So the solid one is pretty easy. You just weigh it on the balance. You use the water displacement method. That's pretty easy. For water, we just read the graduated cylinder, then we weighed it, subtracted off the mass of the graduated cylinder, and then we had the mass. Now this one's tricky because when you have a gas that can you really think about we're surrounded by air. Can we really measure how much there is in there? So if we just kind of did this in an open system, it would just bubble up, travel off into the air, and we wouldn't know how much gas there is. But there is a collection method using this tube called the eudiometer here, using a tube and this bucket of water that we'll get to here in a minute on how to collect the volume. The mass, what we're going to say is that we're going to start with this Alka-Seltzer tablet, this solid here. So if I weigh this before I start, then that's going to be the mass of the gas. However much solid we have here, okay, is how much we're going to have in the gas phase too. So we have 0.56 grams of this carbon dioxide tablet, which is going to turn into a carbon dioxide gas here in a minute. So what we're going to do then is we're going to do the reaction inside one of this test tube here. I'm just going to half fill here with water. So we're going to react it inside this test tube, right? It'll fizz. But if we don't do anything about that, that water is going to travel out. If we just put that in there, it would travel out right into the open. So we got to use this gas collection method using the eudiometer. So the first thing I do is fill this big tube all the way to the top with water, all the way, so that there's no air bubbles inside there. Okay, and then I cap it with my thumb and flip it up. And if I put this inside, if I submerge it in this bucket of water, that water that's in the tube stays in that tube. Okay, right? It will not fall into the water until something happens. Like if I take this out, it's all going to fall out. But at the moment there, this thing is completely full of water. Now, the thing about this is it has little marks on it, like a graduated cylinder does. So it reads, there's the 0 mark is at the top, and then it goes 2, 4, 6. So what happens here is gas collects in here, pushes the water out, and then we can read upside down as to how much gas was in here. In the opposite way we would add a graduated cylinder. So what we do to collect in our test tube here is after we do our reaction, we're going to put this stopper on top of the test tube. Okay, the stopper is connected to this hose. This hose is going to go, undo that for a minute. This hose is going to go inside the water. The end of this hose is going to go under the water. I'm going to tilt the eudiometer so that hose, if you can see, is the end of that hose is spitting the gas into the eudiometer, right? It'll travel through the hose up here, kick the water out, and we'll be able to read how much gas is formed, okay, in that. Okay. So we're ready to go. This is the gas collection method. So if I put that in there and then I cap it right away, right, it is starting to bubble. Right, we're starting to fizz there. Right, it's starting to fizz. Hopefully what we see here in a minute is some bubbles start to travel through the tube and fill up this eudiometer. Can you see those bubbles kind of flowing up the tube now? Right, so the gas that's being produced there, right, is traveling through the tube and into that eudiometer, right? And it's filling up a little bit at the top. It's filling up with gas at the top. We're going to keep this going until that whole tablet is reacted. Shaking it will help a little bit. Right. Okay, we're at like about 18 milliliters of gas now. We still got some bubbles, so because we want to make sure that tablet we started with, 0.56 grams of that tablet, we want to make sure all of that has turned into carbon dioxide gas. I'm just going to keep kind of shaking that a little bit for now. Still, being careful to keep this submerged and everything. But it looks like it looks like that tablet is gone and there's nothing but just water left there. So, and carefully remove that. Okay. And then if you take a look, that eudiometer has maybe somewhere up about here, there's like a water line. And I'm just going to read what that water line says. It is at 20 point, no, it's like right at 20.0 grams or milliliters of water. Okay, so it's right at 20.0. I'm just going to let this go. Now the water will flow out, right, because it's open to the air. Now that gas is free to the air. But so we collected. So we collected 20 grams, or 20, not grams, milliliters. Right, milliliters is the unit of measurement for volume that we use in science and metric. So 0.56 grams turns into 20 milliliters. Okay. So your last question then is to figure out what the density of that would be on your sheet.